So let's look at some simple circuits. Here's a cell and a bulb. The bulb will light. What would happen if you had two cells? Well, you could represent it here. More light, more energy would come off because you've got more energy given to the bulb. So the idea is here that if you add more batteries or more cells together, you get more force, you get more energy, you get brighter bulbs. What happens if you add more than one bulb then? If you've got two bulbs in series, and a series circuit means it's all in one loop, then the current has got to go through two bulbs. So it's got to share its energy out between the two. It sees what's called more resistance, and that resistance means there's less current. So let's look at that in more detail. If a series circuit like this, if you've got 2 amps flowing through the circuit here, that 2 amps is going to go through that bulb, and back, and you've just got one complete loop. Now, like a lot of laws in science, you can't lose current. There's conservation of current. So it doesn't matter where you measure the current in this circuit, it will always be 2 amps. It doesn't matter where you put that ammeter. So the current is always the same. If you look at current in a parallel circuit, so parallel circuits look like this. The bulbs here, that bulb and that bulb are parallel to each other. And what happens is the current will be divided up. So here comes the current. It gets to this bit. Half will go that way and half will go that way. So the current here divides in two, and so the bulb gets equal amount of current. You can get more current. Let's have a look at 3 bulbs. If you put a value on it here, if there was 6 amps coming down here, that would get 2, that one would get 2, and that one would get 2. And then when all of those currents join up again to go back to the battery, obviously you will get the 6 amps there, and that 6 amps will go back through the cell. Let's have a look at voltage or potential difference now, measured with a voltmeter. Voltmeter is always put in parallel. This is parallel to the battery. So if it tells you it's 6-volt battery, it's telling you the voltage across the battery. If you've got bulbs in series, 3 in series here, and they're identical, you've got 6 volts. I'm sure you've guessed it, that each one would share the voltage, and the voltage would be 2 volts, 2 volts, 2 volts to add up to 6. If the voltmeter went across 2 bulbs, because that's 2 and that's 2, you add together, that voltmeter would read 4 volts. Okay, and if we look at voltage in a parallel circuit, when 2 bulbs are put across each other in parallel, you can see they're both connected directly to the battery. So the rule here is that both those voltmeters would read 4 volts, not divine it up this time, they both get 4 volts each. So in summary, in a series circuit, the current is the same at any point, but the voltage will be split up over each component in that series circuit. In a parallel circuit, it's the current that splits up, but the voltage stays the same. Worth remembering these 2 simple rules.